Welcome students to Lesson 1 of the UK's Physical Landscapes. This topic includes both the study of the UK's coasts and its rivers. In the UK's coasts topic, we will be exploring three important questions. The first is, how is the sea affecting the coast of the UK? The second is, why is that a problem? Why should we care? And the final question is, if it is such a problem, what can we do about it? In this first lesson, we will be exploring simply the idea of waves, for they are responsible for shaping the UK's coasts. Please write the date, title and learning objective. Have a pen and paper ready to learn. Time to review prior learning. Write 1 to 10. Answer the questions from memory and then mark your answers. Game time. 1. Energy production. 2. Acidification. 3. Diseases. 4. Eccentricity. 5. Inequality. 6. Trade barrier. 7. LIC. 8. Mechanization. For example, tractors replacing manual farmers on a field. 9. Regeneration. 10. Temple Quarter. Give yourselves a mark out of 10. If you got 8 or more, you've really remembered these ideas. If you didn't, please come back to these questions in a week's time and test yourselves on them again. To introduce this lesson, I'm going to show you a picture, and some questions will appear next to it. Use the picture and your own knowledge to try and answer the questions, and then we will discuss them through the lesson. Here's the picture. What do you think's happening? Take it in. What do you see? Where in the world might it be? See if you can answer these questions. You can do it aloud, verbally, or you can write it down. Pause the video while you do that. So number 1, you should have talked about the waves. It's the sea that's responsible for this. You might have used the word erosion. Number 2, how do waves form? Well, a number of different ways, but the principal cause of waves being formed is the wind, and we will explore that further today. 3. Why are some waves stronger than others? Well, if it's the wind that causes waves, then if the wind becomes more or less powerful, then that will decide the size of the waves. In this lesson, we are going to be exploring 3 vital questions about waves. First of all, where do they come from? How do they form? Second one is, what types of waves are there? And the third one is, what happens to a wave when it approaches the coast? Because that is really important if you want to understand how they can cause events like this in the picture. Let's go. Keyword, the coast. This is the coast. This is also the coast, and this is the coast. It's the area of the land that meets the sea, the meeting point between land and sea, if you like. Please write the word in the definition. As I explain the ideas in this lesson, make sure that you write the subtitle at the top and write brief notes. And I would recommend you do this in flow diagram form, which means you write a fact, you put an arrow down 1 line long, you write another fact, so that you can see how one idea leads to another. Let's do this. Subtitle, underline it, go. How do waves form? Waves are principally, which means mainly, formed by the wind. When wind blows over the sea, there is friction between the moving air and the surface of the water. That friction causes the water to eventually start to ripple. And if the wind blows strongly enough and for long enough and far enough over the sea, these ripples will grow into waves. Like this. So it is the wind and the friction between the wind and the surface of the water that creates waves. Key idea. Please make sure you've written that. Not all waves are the same size though. Subtitle, underline it, go. Wind speed is the first and most important determinant of the size of waves. In a hurricane, winds may be moving at 150 or more miles per hour, and when those winds blow over the sea, there is an enormous amount of friction, building the water up a lot and creating huge waves. By contrast, on a calm day with much more gentle wind, the waves may be much smaller, like this. However, it's not just the strength of the wind that decides how large the waves are, it's also how far the wind travels over the sea. And we call this the fetch. The fetch means the distance that wind travels over the sea, and it explains why some waves are bigger than others. This here, that's wind passing over the sea. And the distance that the wind travels over the sea is called the fetch. As you can see, when wind blows over the sea for a short distance, it just starts with small ripples. But if the wind keeps blowing over the sea, the friction builds up the ripples until they become waves, and then large waves and larger still waves, the further the fetch goes. Let me show you how this works in real life. Here's the UK. When the wind blows from across the English Channel, from France to the UK, the fetch is very short. And so the waves from France are much smaller than when the fetch comes from across the Atlantic Ocean more than 7,000 miles across. The waves become gigantic because the fetch is very long. The wind has had a lot of time and distance to build up those waves. And that's why waves in certain part of the south coast of England are much smaller than waves, for example, in Penzance here, town in Cornwall, or on the west coast of Ireland. So these two factors, the speed of the wind and how far the wind travels over the sea, they determine the size of waves. What happens when the waves reach the coast though? They change somehow, and that's vitally important. Subtitle, underline it, go. This is the sea in the middle of the ocean. Many, many kilometers deep, wind blowing over it, and the waves look like this. This red line shows the height of the waves. In the middle of the ocean, wave height tends to be quite low. And they have an even rolling shape like this. The top of the wave is called the crest, and the very bottom in between two is called the trough. This red line shows the wave length. That means the distance between the tops or the crests of two waves. In the middle of the ocean, the crest of a wave is low, and the wave length is very long. Waves tend to be quite far apart. Finally, the water in a wave in the middle of the ocean rolls around in a circular motion like this. It goes round and round and round. Perfect circle. However, all this changes when a wave reaches the coast. As the seabed gets shallower, the water at the bottom of the wave starts to rub against the seabed. Friction happens. Now, to understand what happens here, I want you to imagine you're running down a corridor, perhaps in a school where you shouldn't be. And then you stop suddenly. Your feet come to a halt. What happens to your body, to your head? Well, your body and your head move forwards. They continue to move forwards even though your feet have stopped. And if you're going fast enough, you might fall over forwards completely. The same thing happens to a wave when it approaches the coast. The bottom of the wave slows down because friction between the water and the seabed slows the lower part of the wave down. But the top of the wave continues to move. And so the wave ends up getting this elliptical orbit. It's no longer circular, it's elliptical because the top of the wave is moving forwards, but the bottom is slowing down. And so the top starts to push over itself. The wave is now taller because the water has all built up. And it's slower. As the coastline gets shallower still, the wave builds up even more, and eventually the top of the wave collapses over itself forwards, and we call this a breaking wave. Part of the water then moves up the beach or up the coastline, and we call that the swash, the wave going up the beach. But then, due to gravity, the water comes back down towards the sea, and we call that the backwash. So because of friction between the bottom of the sea and the seabed as the wave approaches the coast, the wave changes shape, it gets taller, and it slows down. Here's a question for you. Answer it aloud. Why does the wave change shape as it approaches the coast? You should have said that as the seabed gets shallower, friction starts to slow down the bottom of the wave, but the top of the wave continues moving forward. So the wave is no longer a circular shape like this, but it becomes an elliptical shape like this as the top continues to move. And the final question of today is, check out these pictures. Look at how this is shown in real life. Breaking wave, and finally swash up the beach, backwash down the beach. Which brings us to our final question. What are the different types of wave? Because not all waves are huge and dangerous. Subtitle, underline it, go. There are two main types of wave. The first is a destructive wave, so called because it causes damage to a coastline. It makes a coastline retreat, as you will learn more about in future lessons. Destructive waves have several common features. When a destructive wave reaches the coastline, it is particularly tall. The wavelength is particularly short, meaning the waves are very close together. And when the destructive wave breaks, it plunges straight down rather than moving a lot up the beach. They look like this. Because the destructive wave moves very little up the beach, we say it has a weak swash. It doesn't move much water up the beach. Consequently, very little sediment, sand for example, that is carrying in the water is moved up the beach. By contrast, because of the steepness of the beach and because of the amount of water that's just dropped due to the breaking wave, the backwash back down the beach is very strong. And that leads to steep beaches like this, where all the sediment is pulled back out into the sea because of the strong backwash. Swash up the beach, backwash down the beach. By contrast, constructive waves, they build up beaches. They add sediment to a beach rather than removing it like a destructive wave. Constructive waves look more like this. You should be able to tell they have a much longer wavelength, they're further apart. The waves are much lower, and when they break, they don't come crashing down. They flow over the surface of the beach, kind of like this. And that means that an enormous amount of water moves up this relatively shallow beach. The swash is very strong. By contrast, because all that water has been spread very thinly across the beach's surface, the backwash is actually quite weak. There's not much water to pull sediment back out to the sea. And so you end up with a flat beach like this, the kind of beach that many of you will have gone on holiday to. Destructive waves destroy a coastline, they remove sediment because they have a strong backwash. Constructive waves build up a beach because they have a strong swash. Time to assess learning. I'm going to show you some paragraphs with some gaps in them. There'll be words at the bottom. You need to put the words into the gaps. Do not write the paragraphs. Write the following. Put 1 to 14 in your book or on your page, and then put the correct word next to each number, like this. Okay, let's go through. Waves are formed by wind blowing over the surface of the sea. Friction causes the water to get disturbed, start to form ripples, and then grow into waves. When waves are in the open ocean, they have a circular shape. However, when waves approach the coast, friction with the seabed causes the bottom of the water to slow down. This makes the wave topple forward, giving it an elliptical shape. Eventually, in very shallow water, the wave breaks onto the beach. The Swash is the water going up the beach, and the backwash is the water coming back down into the sea. Constructive waves have a long wavelength and a strong swash, which causes them to build up a beach. Destructive waves are tall and have a short wavelength. They have a strong backwash and so pull sediment back into the sea. This can destroy a beach. Give yourselves a mark out of 14. If you got 12 or more, you really mastered and understood this lesson. However, to develop your understanding and strengthen it further, you need to practice it. I'm going to show you some questions. Answer them using your notes if need be, and then mark your answers. So the first one is asking you about the fetch. Use that idea. You should have said about the distance of the wind that travels over the sea between France and the UK versus the distance from South America. Question 2. So I described the differences in the shapes of the waves and what they do to a beach. You could have talked about any two of those, such as these things. And finally, number 3 was all about friction. Give yourselves a mark out of the total. If you lost any marks, make sure you add the corrections in green pen. Well done today. I'm very proud of you for having completed this lesson. You have learned a lot. Join me for next lesson of the coast topic.